So, hello and welcome to this video. I'm here because I want to show you this little project about machine learning. It's about specifically an image segmenter, this whole code. So I'm gonna show you, I'm gonna explain it, and I'm gonna make some tests for you so you could see how it behaves. So let's begin. First of all, we have here the library that we're going to be using. Notice that we have a TensorFlow based code. Then we have here what is the structure of the model. We want to build what is called an autoencoder. That's the architecture that we're gonna select for the model. And for that purpose, we need to build three blocks here, three blocks here. One is the encoder here, the other one the bridge, and the third one is the decoder. For the encoder is made up by using two convolutional layers. Then this is in charge of compress the data until it arrives to the convolutional block of the bridge convolutional layer, and then this bridge passes the data to the decoder, and it is in charge of samples the data until it arrives to the input data size or the original data size. So it's basically the idea of an autoencoder here, and nothing more. So we can conclude this part with returning the model. We have here, for example, what is the previous trained one. We have here the features of the model. For example, we can see here how the size of the input is or of the model or of the data is decreasing by passing through the convolutional layers, and then how it's increasing with the upsamplers here. Once we have understood this, we can go to the data loading section here, and this part allows us to retrieve the data where they have been stored. So this idea here, retrieve the data. So for example, here is in this for or in this loop. We're going to retrieve all the data about the training dataset, what is input and target. And here in this loop, we are retrieving the data or the training validation dataset, including the input and the target dataset. So that's the idea here. We can even go to that part of the code here, to the path. Follow the path that is here in the code, and take a look to what is there. So let me go there. Here we have the training. This is in Spanish. Sorry for English readers. This is the validation. So let's see a little bit about the training data. We have here the input, and like you see here, we have a kitty photos. These all are kitties, or photos of kitties. So yes, this is basically the image that we want to put inside to the model. And I want to point, or just at this point, I want to highlight one thing about the dataset is that it can be too small for a real world application. But like I'm doing a didactic video, or my idea is to make a demonstrative video, and I'm not needing to make high-end data set for the demonstration. So I think with this I'm gonna be okay. We're gonna be okay with this size of the data set. So let's having said this, let's back to let's gonna see a target now. What we're gonna get once we have put the input images to the model. This is what we're gonna get. So take it into account. Let's see, for example, the validation. It should be the same structure. Here we have the mask or the target, and again the input here. Is okay, sorry, that's the the point is that is the same structure. We have here the input and all these photos of cats and the masked ones here. Yeah, that's the thing you need to do to know. So once we have cleared this part, we can continue with this part that is the relation is related to the transformation of the data set. This is needed because can enhance the performance of the training. So this part is for this, the transformation. So then we have here what is the feeding of the model. We have here all related to the feeding, to the learning processes. And we can see here the hyperparameters. For example, we are here with the hyperparameters. We need to define the loss function and the optimizer we're going to be using. And for example, we can we define here callbacks. One for defining the path where we're gonna be saving the model, and one, for example, to make the anomaly stopping. This is for this is a regularization method for avoiding or trying to avoid overfitting. So this defines the training process. We can say it. So now I'm gonna tell you that I'm not gonna train the model again because it's uncertain the time that it's gonna take, but often it has been taking a good time. So I preferred to make a training model here, save a model before, and make the predictions with this model that I have already created. So let's do the inference or the testing. We have here what is the tester code. It uses, like I said before, that model that with that name here, and retrieve the model. If it is successful, then it can make the predictions, and it saves the image into this path. So we can now make a test and make how it works. So let's run this. I hope testing date. Okay, this should be appearing here soon. Okay, so let's see first of all the cat image. Like you see, this is the cat, the real cat, And let's compare with the result. Okay, it's a good result. We can see that it's a relatively good result here. We can see shape of the cat. So we can say that it works, and it works better even if with a good quantity of data. So let's test another. Let's test with another another file or with another image. We have here another like test2. Let's run this. Let's go to the folder. It's going to be appearing. Okay, let's see the cat first. We have here a cat, the legs of the cat. It's a really beautiful cat. Now we can go to the result and see, okay, and we can see a shape of the cat until it's not perfect. We is maybe with like I said before, with some other with more a biggest size of the training set data set, we could get or hope better results. But yes, this is the cat, and we can see this shape here. So that's it. Hopefully you gonna enjoy this video, and I wait to this could be clear for you. So thank you for watching, and goodbye.